it's finally here. The tutorial video for the K-TAC RTE-1. I know people have been waiting forever, and I'm really sorry on how long it took for this video to come out, but there's been a lot of crazy things going on in the lab, and a lot of cool stuff we're really excited to show you. I can't believe this video is finally out, and I hope you really enjoy it. Now, before I get started on this video, for those of you who don't know what this project is about, go ahead and watch the first two videos on it. We'll link it down below. Now, secondly, some people have been asking and getting a little confused with the RTE-1 project as a drop-in solution for their T-beam, and I'm very sorry to disappoint, but this is a little bit of a complicated project that I highly do not recommend for beginners. It can be very overwhelming. Please check out all the amazing cases that the amazing Meshtastic community, who by the way made this project possible, have shared and designed online. Now, if I had to recommend one out of them, I would highly recommend Mr. TonyG's Cases. I absolutely love his case designs. They're simple, they're easy to print, and they're really durable. In fact, they're more than enough durable for, I would say, 99% of the people watching. This is kind of overkill even for myself, and his cases are plenty durable, much easier to print, and it doesn't require crazy modifications to the T-beam. So really check his stuff out and give him the credit he deserves. If you don't have a printer or don't want to print them for some reason, he also sells his cases at a very fair price. And even for viewers who are interested in the K-TAC RTE-1, if you ever are in a situation like I was where I need to make a bunch of cases for a bunch of people, this can be overwhelming. This may be for more of the advanced hardcore users, but let's say you have a group of like 20 people and you just need to give them simple cases. You may be interested in really good durable 3D printable designs that are much simpler like his. So please go check him out. And also check out the other cases too, in case you're interested. Now, before we get started, make sure you go and check the GitHub page so you know all the parts you need and the basic overview of everything, and also source all the parts you need. Secondly, go ahead and 3D print all the parts you need. And finally, you're going to need to CNC machine some parts. Either CNC it yourself if you have access to a CNC machine, or you could get them CNC cut by a service. One of my favorite services is Send. I'm not paid by them. I have absolutely no affiliation with them, but I just love their service. They're fair price. They're based in the USA and they're very fast. So they can actually cut the acrylic panel for pretty cheap. Their carbon fiber service is a little bit on the pricier end. So you could actually substitute it for things like aluminum or other materials. So choose what you want and order the parts that need to be cut from them. Now, enough talk. Let's get started with the tutorial. We have all the parts sourced and organized, and we're ready to proceed with the build. We're going to start out with the 3D printed parts. Upon close observation, you can view that there's excessive support material and other excessive materials that are unwanted and should be removed. One of the tools that make removal of supports easy is a flathead screwdriver. Now use pliers, X-Acto blades, and other necessary tools to clean up the prints and remove the supports, and take your time. Now you can see this demonstration of adding brass threaded inserts heat set in with a portable soldering iron. Now this process needs to be done on the center frame on the 4 large holes. Repeat on both the front and back and use M3x6 brass threaded inserts. The same process needs to be replicated on both sides of the center frame by using shorter M3x3 brass threaded inserts. Again, locate the 4 large holes on both sides of the center frame and add the threaded inserts in. Now it's time to grab your M8N T-beam. Now, observing on the back of the T-beam, you can see the 18650 tray. They need to be removed by desoldering these 2 large contacts. But before we proceed with desoldering, remove the two antenna connectors since they're fragile. During removal, be very gentle with them and set off the two connectors off to the side. Then proceed with desoldering the 18650 battery tray. Once desoldered, it should look something like this. Now it's time to grab your battery wire and the battery connector of choice. In our case, we're using an XT30 connector. After soldering on the connector and adding the necessary heat shrink wrap insulation on the connector side, it should look something like this. Now the T-beam is ready to accept larger capacity batteries. Now pay attention to this part. On a normal T-beam, the OLED is soldered directly onto the board. In our case, our OLED needs to be offset, so we're going to use a series of wires to replicate the same connection. Now the wires can't be too long or the OLED display will not work, but not too short to hinder our ability to offset the display. We're using thin gauge silicon wire in our case. So we have the display and the silicon wire, and we're going to attach about 3 to 4 inches of length of wire to each connection point on the OLED display. The wires can be trimmed down later. After soldering on the wires, it should look something like this. We prefer soldering the wires to the backside of the display. It doesn't matter on the final end product, but it makes integration of the OLED just a little bit easier. It's time to solder the end of the silicon wire onto the T-beam, and this is the part to pay close attention. The connections on both the T-beam and on the OLED are well labeled, so triple check these connections as you solder them on. Once they're soldered, it should look something like this. Now it's time to grab your male micro USB breakout. Oftentimes these connectors are a little tight, so they need to be pushed into the T-beam with moderate pressure, being careful not to damage the connector. Once it's pushed in all the way, it's time to grab the center frame to give us a better idea and judgment on the sizing of wires. Align the T-beam to the center frame and you can see how it's going to fit, giving us a better idea of how wiring will go. Now grab the micro USB waterproof panel mount and disassemble the panel mount assembly, which involves removal of the plastic hex nut and the dust cover. Now set off these hardware to the side because we're going to need them later. Now it should look something like this. Now you can see that the panel mount ridge is a little bit too tight for the RTE-1 case and it needs to be trimmed down. We like to use a pair of snips to snip away the excessive plastic. Now when doing this, be careful not to snip away too much material and leave at least a 1mm rim. After snipping, it should look something like this and it's ready to integrate directly into the center frame. Now heading off from the back side of the frame, we're going to insert the panel mount and it should fit something like this. If there's any high points or ridges, go back to the previous step and trim them off. Now add the dust cover and the plastic hex once again and tighten the whole assembly. The panel mount should look something like this when finished. Once that's done, fish the wire toward the front, and now it's time for the T-beam just as a size measuring guide. Now bend it in this U shape and judge the rough distance to the micro USB port, add an inch of extra wire, and cut that point. Once the wire has been cut, you can save the micro USB for some other project. Using a pair of wire strips, gently remove just the exterior sheath, preserving the wires on the inside. Pull back the insulation and expose the 4 wires. The wires are going to solder onto the micro USB port from this direction. Now pay close attention. The orders are black wire at the top, green, white, and red wire at the bottom. Triple check these connections on your micro USB breakout so you don't damage the T-beam. Once soldered onto the micro USB port, it should look something like this, and you want to fish that wire to the back of the T-beam. Now you can see that the connection is a little bit fragile, so applying a little bit of hot glue around it is a good idea. After the addition of hot glue, it should look something like this. This step is optional, yet highly recommended. Now grab your 4 M2x4mm screws and align the T-beam to the center frame, ensuring that the battery wire and the USB wire go to the back. Now the tolerances are tight and the T-beam can be easily damaged with improper tension, so go corner to corner. Once the T-beam has been secured to the center frame, it should look something like this. Now grab the thin gauge silicone wire, and it's time to jump the buttons. We're going to jump the power button and the mode button at these 4 solder points we're pointing out here. After the precision soldering, it should look something like this. And we're going to grab the right side button panel. And we're going to use some M3x4mm screws to secure it in place. Use moderate torque when securing the side panel. Too much and the stainless steel screw could strip the brass threaded insert. Once the side button panel is secured, it should look something like this. And it's now time to fish the button wires. So quite obviously, the top button wire will go out the top button hole, and the bottom button wire will come out the bottom button hole. After that's complete, you want to grab your 2 13mm stainless steel waterproof momentary buttons. The buttons will solder onto each of their respective wire pairs, and it should look something like this. Once that's done, you want to push each button into the carbon fiber panel, and it should snap into place. Now, it's wise to add a dab of hot glue, even though the pressure fitting should be pretty tight. Now it's time to grab your SMA connector and your Suricom 25mm patch antenna. The GPS antenna should be fished from the back, from the hole on the T-beam, pulled to the front, and attached to its respective GPS antenna port. Be very careful, these tiny antenna connectors are very fragile. Now it's time to fish the SMA connector from the button side on the back of the assembly and push through the hole. After doing so, the antenna wire should be fished underneath the power battery wire and the USB wire and fished toward the front and guided into the LoRa antenna output. Once the SMA connector is in place, it's time to get the brass tension ring and a brass nut to secure it in place. Be very careful, brass is a soft material and can be easily damaged. Torque it down with very light and moderate tension. Now the assembly is really coming together, and you can see that everything's in place and well organized. It's time to focus on the front panel. Grab your Lexan or acrylic front screen protector assembly. And making sure the Meshtastic logo is upright and in the correct position, remove the protective film from the bottom and set it off to the side. It's time to choose your adhesive, either using electronic grade silicone or quick epoxy. In our case, we're going to use silicone since it sets slower. A syringe and blunt needle is one of the best tools for applying either epoxy or silicone in a very precise manner. Apply a very fine, thin bead of silicone or epoxy around the front panel crevice designed to hold the screen protector. And once that's done, grab the screen protector and double check the Meshtastic logo is correct one more time, and on the film removed side, facing down, push the screen protector into the front panel. Now remove the front screen protective film. After the peel, it's time to get your carbon fiber front panel plate. Make sure the tolerances all fit. Afterwards, grab the screen tray. The screen tray will need 3 M3x3 brass threaded inserts, which we've inserted right here. Depending on your tolerances, this step may or may not be necessary. Afterwards, screw the whole assembly through the screen protector and through the front panel and into the front plate. Add some silicone sealant behind the front panel where the screws are contacting to seal it. Now grab the screen tray and fish the OLED display through the inside. Make sure the curved points are pointing upward. Now remove the protective film on the OLED display. Align the OLED on the Windows screen on the front panel, and place the screen tray behind it. Make sure the OLED display is aligned and tighten the front 4 panel screws. Some adjustment may be necessary. Now that that's complete, the front assembly should look like this. It's time to grab the silicone sealant one more time and seal off the panel mount, the SMA connector, the buttons, and very importantly, the side panel screw holes. On the button side, we've done it from the inside. Now add a bead of silicone around the edge of the center frame. Now the bead of silicone has been applied all around, it's time to align the front panel. We're going to grab 4 M3 by 12mm screws, and we're going to screw in the front panel. Take your time here and make sure none of the components are getting smashed or damaged inside. Make sure the cables are all in the right place and nothing is getting caught. Now that the front panel is sealed, it's time to move on to the battery. In our case, we're using 2 recycled 21700 cells. We're going to solder the 2 cells in parallel with the XT30 connector. If you own a battery spot welder, it is highly recommended to use that. Our battery pack has been sealed up now with battery wires, an XT30 connector, and electrical tape, and we are going to connect it to the RTE-1. Now we're going to get some 3M double-sided tape and cut out a small strip. This is for the GPS antenna. That tape is going to be placed on the angled fairing side in the back plate. We're going to place the tape inside. And now it's time for cable management. Stuff the battery cables by neatly coiling them in the back and place the battery in the back. Now place the Sericom antenna on top of the battery. We're going to now very gently place a small bead of silicone all around the edge, just like we did in the front panel. Now this is the tricky part. Align the 25mm patch antenna gently onto the double-sided sticky tape on the fairing and gently press the back panel into the center frame. We're going to secure the back with 2 M3 by 12mm screws on the bottom and 2 M3 by 6mm screws on the top. Now your RTE-1 unit is almost done, just need to add the side accent panel. Now your RTE-1 is finished. Time to screw in your LoRa antenna, and there you go. You have a final operating unit. Make sure you test all the functions of the device and debug as necessary. Well, oh boy, that was a lot and a very long video. And if you watched it all the way up to here, well, congratulations and thank you so much. And if you build your own or have any feedback, feel free to share it because all your community feedback does heavily influence the improvement and maturity of our projects. And it's really awesome to see what other people come up with. If you want to modify this design, all the CAD files and whatnot are on the GitHub repo for free for you to tweak with and tinker with and really check out. Thank you so much for watching and stay tuned because we got some really awesome projects in the work. See you next time.